Welcome back to Thought Kernel, where we break down educational concepts deeply, not just to understand them intuitively, but to also understand their applications in the real world. Today, we're going over Euler's identity. This is the most beautiful equation in all of mathematics. E to the power of I pi plus 1 equals 0, aka Euler's identity. It connects five of the most important numbers in math. But this isn't just a random formula, it's a deep truth. A bridge between seemingly unrelated worlds, exponentials, geometry, and complex numbers. Today, I'll show you the meaning behind this magical equation using nothing more than basic math and some mind expanding visuals. We have an abundance of infinite numbers in Euler's identity, which will play into its repeating pattern, which we can see visualized on graphs later. The power of repeated change. Let's start with something we know, exponentials. E to the power of x, represented on the left, represents continuous growth. If you deposit money in a bank and let it grow forever, it's e to the power of x. Exponentials stretch out along the number line. They get big fast. But what happens when we raise e to an imaginary power like e to the power of ix? In what we have, the unit circle, showing the imaginary numbers and how they're displayed, we can imagine that some type of motion will be spinning around this circle in however Euler's identity moves. And now we're going to try and figure out how E will move to the power of I times pi. Imaginary numbers, turning instead of stretching. I'm not sure why these bars are turning. I couldn't get them to stop. They're not even animated. I have no idea what's going on. But let's continue. The imaginary unit I is defined as the square root of -1. It sounds fake, but it's just a new direction of math. Instead of stretching like real numbers do, multiplying by I rotates things. If you start at 1 on the number line, multiplying by I turns you 90 degrees to land at I. Do it again, and you rotate to -1. So where real numbers scale, imaginary numbers spin. And we can see this by what was supposed to be the graph and how it moves around each part of the axes. And this is supposed to visualize how it spins around and will play into what I said earlier, the visualization of the graph. Now entering the complex plane. We're going to be mixing real and imaginary numbers and producing what we call the complex plane, like a 2D map of numbers visualized. Think of it like a coordinate system. Left to right is real, up and down is imaginary, like 1 and -1 and I and -I. Now, what if we use exponentials to move on this plane, like e to the power of I pi? Amazingly, raising e to an imaginary number doesn't move us out into space, it moves us around in a perfect circle. So hopefully pi should somewhat play into the movement forward displayed by the complex plane visualizations. Now, furthermore, how exponentials create circles. Here's where it all comes together. We usually think of exponentials like e to the power of x as producing growth, something that shoots off to infinity. But when we plug in an imaginary number like ix, which would be replaced by pi in this case, something very different happens. Instead of growing outward, e to the power of ix rotates. As x increases, e to the power of ix moves around the unit circle like a clock hand sweeping out an angle. It doesn't spiral out, it doesn't shoot off, it stays on the edge of the circle. That's because imaginary powers of E encode pure rotation. Now, exactly what happens when we rotate by exactly pi radians? That's 180 degrees. Starting at 1, -1. So this gives us e to the power of I pi equals -1. Add 1 to both sides, and e to the power of I pi plus 1 equals 0. What started as a journey around the complex plane leads to a collision of the most fundamental numbers in mathematics. It's not just coincidence, it's geometry, algebra, and rotation all wrapped into one, and displayed by the complex plane on the previous slide. Let's stop and take in what we just witnessed. This equation, e to the power of I pi plus 1 equals 0, is more than just correct. It's astonishing. It links the 5 most fundamental numbers in all of mathematics in a single perfectly balanced statement. Let's walk through them. E. It's the base of exponential growth. It shows up anytime something grows continuously. Populations, radioactive decay, compound interest, it's the rhythm of the natural world's change. I. I is the imaginary unit, a whole new direction in mathematics, unlocking the complex plane and giving us rotation, oscillation, and wave motion around the circle. Pi. Pi is a geometry's constant, the ratio of a circle's circumference to its diameter, linking straight lines and curves in a way that no one fully saw coming. Then we have 1, the multiplicative identity, the anchor of all number systems, multiplying by 1 and nothing changes. And finally, 0, the concept of nothing, the additive identity, the invention that made modern math even possible. This one equation gathers them all and balances them perfectly. An exponential raised to an imaginary power involving pi plus 1 gives 0. It's almost like the universe wants these ideas to be connected. Not because we forced it, because the structure of math itself says that these terms belong together. Now, closing off. This is Euler's identity. And Euler's identity isn't just useful, it's poetic. It reveals that math is more than just rules, it's a story of symmetry, connection, and surprise. If this equation exists, maybe the universe really is written in the language of mathematics, uniting these terms together to build one of the fundamental ideas that encompasses all types of mathematics to produce complex visualizations that contradict math.